Assalamualaikum and salam sejahtera to all teachers, students, viewers and to all my subscribers out there. Thank you very much for your wonderful support. And to our new visitors, welcome to my channel, Cikgu Hasnita. This is Physics Form 4 KSSM for DLP classes, Theme 1 Elementary Physics. Today will be our 5th lesson on Chapter 1. And students, if you are good to go, you may get yourself comfortable, get ready with your textbook and your exercise book as well. And let's check this out. Alright students, so in our 3rd and 4th lesson, we have briefly discussed what is the importance of interpreting and analyzing graph. Okay, so today let's check your understanding by try these few exercises which you can find in your textbook. So first, let's deal with this activity 1.3. So what do we have here? Sarah is in the house. Hey. So Sarah is carried out an experiment to investigate the relationship between force F and extension of a spring X using the apparatus set up as shown in the figure. So you can see clearly the figure is down there and the result of the experiment are shown in the table. So you have to assist Sarah to analyze the graph and to help her to summarize her investigation. So first let us check what are the apparatus and the result that we have here. So you can see this is our spring. It is hang on a retort stand given the initial length when there is no load hang on it. And at the other side, this is what happened to the spring as long as we place a force or a slotted weight at the end of the spring. So you can see the spring is started to extend and the extension is given by X. What does extension means? Very good. Extension is the difference in between the final length and the initial length of the spring. And you can see from the table of result, she is begin with a force of 0.5 Newton given an extension of 0.8 centimeter. And she increases the force up to 1 and finally to 4 Newton. And the extension, if you can see from this table, it is also increasing from 0.8 to 1.6 and finally to 6.4. So what are the questions that follow? Let's check on them. Alright. So if we check from here, there are 3 things we have to work on with. First, you have to plot a graph of F against X. And second, to analyze your graph based on the following aspects from A to F. And finally, to present your graph and the analysis of graph. So let's do this together. Okay, so for question 1, they ask you to plot a graph of F against X. So how to plot a graph of F against X? Which one have to be on the y-axis and which one has to be at the x-axis? So F against X mean graph of Y against X. So F has to be on the y-axis and X, which is the extension, need to be plotted at the x-axis. Very good. So this is my graph which I have plotted and I hope you also have plotted your graph and then you can compare them with mine. Okay, so now let's check with number 2. You asked to state the relationship between F and X. So from this graph, what can you say about F and X? So first, you have to check on the type. What type of graph we have here? Remember how to check for type of graph. There are 3 things which you have to look at. Number 1, either the line is a straight line or a curve. Second, the gradient, positive or negative. And third, either the line pass through the origin or not. Okay, so for this graph, what can we say about it? Very good. It is a straight line with a positive gradient and passes through the origin. So this will give the relationship between F and X where, yes, F is directly proportional to X. Easy, right? Okay, let's check on B. You are asked to calculate the gradient of the graph K. also you have to show on the graph how you determine this value. So let's check back on our graph. So remember how to determine a gradient from a straight line graph? Very good. It is y2 minus y1 divide x2 minus x1. So how to find this value? Very easy. You just pick any 2 points along the line. So I choose the first point and the 8th point, where each is 0.8, 0.5 for the first point, and my 8th point is 6.4, 4.0. So I substitute the value into the formula. So up there, 4.0 minus 0.5 Newton, which is force, y-axis, divide 6.4 minus 0.8 centimeter, which is the extension. So by this, the gradient is 0.625 Newton per centimeter. Okay, then how to show? Okay, how to show? We show this gradient by drawing a triangle which connect these 2 points. So as you can see, my triangle is there. Okay, now how about C? What do we have here? The equation that relates f and x is given f equal kx, where k is the spring constant. And you have to determine this value of k in a SI unit. Okay, first and foremost, what is spring constant? Spring constant is a value which represents the stiffness of a spring. Okay, how hard the spring is. If the spring constant is higher, means the spring is stiffer, a hard spring. When the spring constant is lower, means it is a soft spring. Okay, so back to our question. So how to find K? So actually, if you look at this question, this is a linear equation for a graph which is directly proportional. So K is actually, we have calculated in B, which is the gradient 0.625 Newton per centimeter. But this unit is not in SI unit. So we have to convert it into SI unit. So what is the SI unit for spring constant? It is Newton per meter. So how to convert centimeter into meter? Very simple. So, okay. So this is how we do the conversions of unit from centimeter to meter. 1 centimeter equal 0.01 meter. So we divide 0.625 with 0.01. So the value for K in SI unit is 62.5 Newton per meter. And now let's move to D. Okay, D, you are given the area under the graph represent the work done in stretching a spring. So you have to determine the work needed to stretch the spring by 5 centimeter. Okay, so the work done in stretching a spring is also equal to the amount of elastic potential energy stored in the spring whenever the spring is stretched or compressed. So work is equal to elastic potential energy stored in a stretching or compressing spring. Okay, so it says that the spring has been stretched by 5 centimeter. So remember how to determine area under the graph. So you have to look what is the shape of the graph. So where is the extension 5 centimeters? So you can see I mark with an arrow here where the extension is 5 centimeter. So we draw a straight line from this X, which is 5 centimeter, to the graph line. Okay, and we shade this area. So the shaded region or the shaded area, this is what we call as the area under the graph. And you can see it has a shape of a triangle. And from here also you can see that the amount of force need to stretch the spring by 5 centimeter is 3.1 Newton. Okay, so how to find the area? by applying a formula for area for triangle. Yes. So what is the formula for area for triangle? It is half multiplied by f multiply x. Okay. Where f is 3.1 Newton and the extension is in meter. Okay. Extension must be in meter, 0.05 meter. Okay. Why we have to convert the extension in meter? Because the unit for work is joule, which is also equal to Newton meter. So that's why we convert the extension from centimeter into meter. And this will give you the work done of 0.0775 Newton meter, or also equal to 0.0775 joule. Okay, now let's check for E. You are asked to determine the value of F when given X is 3.5 centimeter. Remember our previous lesson? One of the most important aspects in analyzing graph, when you are given either X or Y, you can determine the other value by doing, very good, interpolation. Okay, so how we do interpolation for this graph? So look at the x-axis where extension is 3.5. So we draw a straight line from that point up to the graph line, and from there we draw a horizontal line to the x-axis. And you can see F is 2.2 Newton. So when X is 3.5 centimeter, the force applied is 2.2 Newton. Okay, now we have come to F, where you have to predict. You are asked to predict the value of X when F is 5 Newton. So how we do prediction? Yeah, by doing extrapolation. So how do we extrapolate this graph where the force is 5 Newton? So you can see from the original line, when force is F Newton, is actually out from the range. So we have to extrapolate the final points as shown by this red dashed line, and from there we draw a line from force 5 Newton towards this line, towards the extended line, and from there we draw a vertical line down to x-axis. And down there you can see the extension is, I zoom it for you, yeah, so you can see the extension is 8 centimeter. So by doing extrapolation, we have predict when F is 5 Newton, the extension is 8.0 centimeter. Okay, so it seems that we have done doing the graph analysis from A to F, and now I present to you my graph, which all can be settled just with one piece of graph paper. So I hope you enjoy doing activity 1.3, and now let's continue with this practice 1.2. Okay, so what do we have here? Question number 1. A graph plays an important role in a scientific investigation. Nobody can deny that. A. What are the uses of graph? So what do you think? What are the uses of graph? Yes, in scientific investigation, a graph is used to determine the relationship between the two variables from the data collected. Okay? And second, explain the main steps taken in the process of plotting a graph. So what are those steps you have to follow in order to draw or to present your graph? So number 1, first you must identify the variable. Which one is the MV, which one is the RV? From where? From the data collection. Okay, second, we have to determine the variable range. Okay, look at the reading. How is the range? What is the smallest value and the largest value? Why? because later you have to choose your suitable scale to plot your graph. And this scale, it must be even and uniform for both. Okay, in the next chapter we will talk more on what even and uniform means. And then number 4, you have to label both axes of x and y with the quantity together with the corresponding units, and also give a title to the graph. Graph of y against x, graph of force against extension of spring. And number 5, to determine the data points and to plot them on the graph. So you have to plot exactly at the correct place for each reading. And finally, to draw your graph. Okay, how about the next questions? Okay, now you are given a figure. It shows a graph obtained from a study to investigate the relationship between volume V and a temperature theta of a fixed mass of gas. And based on the graph given, you have to answer the following questions. So this is the graph you are given, a graph of volume in cubic centimeter over against temperature, which is in degree Celsius. Okay, the first question, what happened to volume when theta increases? Okay, first again, what type of graph we have here? It is a straight line graph with a positive gradient. It doesn't pass through the it doesn't pass through the origin, but it intercepts at the y-axis. So we call this type of graph as V increases linearly with theta. Theta is temperature. Okay, now what happened to V when theta increase? You can see clearly from the graph, V increases. Okay, when theta or when the temperature increases, the volume also increases. Okay, now look at the next question, B. Okay, here you have to determine the value of theta when the volume is 0. So what is the temperature when volume is 0? So where the volume is 0, okay, so how do we get this? We can do this by again doing extrapolation. So how do we extrapolate? We have to extend the line of the graph until we meet where volume is 0. So if you look here, this is where volume is 0. And what is the temperature there? It is exactly in between -200 and -300 degree Celsius, where the temperature is -250 degree Celsius. Okay, then how about C? Okay, C, you are asked to determine the value of volume when the temperature is 300 degree Celsius. And you have to show on the graph how you determine this value of V. So this is the extended line we draw previously from question B. So where is a theta or temperature 300? So this is where temperature is 300. So to find the value, we do interpolation. So we interpolate from the temperature 300, and from there we can get the volume is, okay, it is 22 centimeter cube, okay, or 22 cubic centimeter. So that's all for now. Today we have completed doing activity 1.3 and formative practice 1.2. Thank you very much for your effort, and also thank you for your support. So join me again in our 6th lesson. What will it be on? Surprise. So if you don't want to miss my classes, don't forget to subscribe into my channel and hit the notification bell as well, so you will be among the first who get notified whenever I'm uploading my latest video on physics. Till then, take a good care of yourself, and till we meet again, Assalamualaikum and have a great day. Remember our tagline? belajar demi ilmu, fizik di hatiku.